All right, folks. So what we're going to do here is we're going to look at um, another example for modeling a linear relationship. And remember, when we do this, we want to start by deciding which type of equation is going to be best for us. Are we dealing with slope-intercept form, where it's a rate and an initial value? Or is it a total problem where we have two parts that we're adding together to find a sum? And like we saw in our last example, we the order that we add doesn't matter. We have this commutative property of addition that allows us to add in any order. So the x doesn't necessarily have to come first. You might have to look at the graph if you're given a graph and the labels on the axis to decide which one's your x and your y. But let's look at an example here and let's see what we can actually come up with. Go. In this problem, we need to decide if we're going to use standard or slope-intercept form. And then we need to write an equation to describe the problem. Let's remember, though, our procedure for doing this. Our procedure for this is that we are going to start by analyzing the information. To analyze the information, then make a plan, and then write an equation for it. So let's look at some of the information we're given. The members of a wheelchair basketball league are playing a benefit game to meet a fundraising goal of $900. So we have a goal of $900. The tickets cost $15, and that's going to be $15 per ticket. And snacks cost $6 each, so $6 per snack. So if I look at this information, it looks like, again, I have a total and two rates, two things that I'm charging for. Well, the price of tickets, the money I'm going to make off of tickets, if I sell one ticket, I'm going to make $15. That's not very much. But if I sell 100 tickets, I would take 15 times 100. So my expression would be 15 times T, T for tickets. And if I make $6 off of one snack, if I just sell one snack, but then if I sell 100, well, how much money would I make from that? Well, that would be figured out by taking 6 and multiplying it by 100. So we'll take 6 times our snacks, and let's call our snacks, we can call them S. S for snack. So I have 6S plus 15T. And that's the way I'm making money. So I know, just based off that information, I know that if I take the money I make from tickets, tickets, not an E on there, silly. And I add to that the money I make from snacks, that'll be my total amount. That is my total. Now, in this case, we want the total to be 900. So our total here is 900. That's what we're told to do. Our total should be 900. Well, now we can plug in our expressions. The money from tickets, the amount of money I make from tickets is given by $15 for each ticket. And the amount of money, if I add to that the money I make from snacks, which is given by 6S, 6 times S, not 6.S, 6 times S, if I add to that 6 times S, I'll find my total amount. So again, it wants us to graph the linear equations, and we can do this probably most simply by finding the intercepts. So if we find the intercepts, remember those are where I have 0 for one of my values. So let's just say that instead of deciding right now, which one is x and which one is y. Let's start with our equation here. It was 15t plus 6s equals 900. 15t plus 6s equals 900. And eventually I'm going to plug in 0 for both. So let's say on this side that I make t 0, and over here I'm going to say s is 0. And then I can kind of split it and work two things at the same time. Well, if I plug 0 in for t, here we go, 15 times 0 plus 6s equals 900. So I'm plugging in 0, 0 is taking the place of t. 15 times 0 is 0. 0 plus 6s is equal to 900. Well, 0 plus 6s, that's just 6s. That is success. Well, then to solve for s, I would divide by 6, and I'm going to. And I see that s would be 150. Now let's talk about what this means real quick. This might not be the most likely situation because this means I'm selling 0 tickets. If I sell 0 tickets, or if this wheelchair tournament, basketball tournament, if I sell 0 tickets, this is an L, 0 tickets, in order to meet my goal, I would need to sell 150 snacks. And the reason I might say that that's not real reasonable is because if I don't have anybody there, who am I supposed to sell snacks to? That doesn't always make much sense. But for the case of this equation, that's how I would need to meet my goal. Well, if s is 0, and we plug 0 in for s, so I have 15t plus 6 times 0, I still want my total to be 100, or 900. I plug 0 in for s. Well, 6 times 0, that's 0. So that's 15t plus 0 is equal to 900. Well, 15t plus 0, that's just 15t. Still equal to 900. Then to solve for t, I know I need to divide by 15. I know that t in this case then, t will give me whatever 900 divided by 15 should give me 60, I believe. Yeah, there we go, 60. So this one might make a little bit more sense because if I sell 0 snacks, if I don't have any snacks to sell, so if this tournament sells, if they sell, or if they sell 0 snacks, in order to reach their goal, they would need to have 60 people sell 60 tickets. They would need to sell 60 tickets. Okay, so we've got 0, 150, and 0 and 60. So let's look at a graph here because they give us a graph to decide which ones are X and which ones are Y. Well, if we look at the graph, the X-axis is labeled with tickets. So that means when I look at an ordered pair for this problem is going to be tickets, the number of tickets, and the number of snacks. because my tickets is my X value. So if I write an order pair for both of these, how many tickets did I sell here? Well, I sold 0 tickets, and I would have to sell 150 snacks. And if I sold 0 snacks here, I would need 60 tickets. So we've got our 2 points for our graph. We've got our 2 points now. 0, 150. This looks like it's going by 20s. 20, 40, 60, 80, 100, 120, 140. 150 is going to be right in the middle there. And then 60, 0, 20, 40, 60 will get us right there. And again, if we use a straight edge or a ruler, we can create a nice line for it. Maybe if I can line these up. There we go. That looks pretty good. Now, one of the things that we need to recognize about this graph is that I kind of had to approximate this 150 here. So if I don't know for sure that this point was at 150, the rest of the points could be off a little bit too. So let's see what the last question we need to answer here is. It says, if the team sells 50 tickets, so they don't reach their goal of 60 tickets, how many snacks does it need to sell? So I can use this graph, but again, this graph might not be perfect. So it looks like 50 could be somewhere in here. Maybe that's not perfect, but we would need to guess. So if I look at 50 tickets and I go up to where it intersects my line, where my X value is 50, and then I look at where this point is on the y-axis, what is the y value at this point? It looks like I might say that, well, this looks like it's approximately, if this is 20 and this is 40, this looks like it's pretty close to 30. But I can't say for sure. If I want to know for sure, and I do, if I want to know for sure, I need to use my equation and plug in 50. So here we go. Let's do it. I have my equation right here. I want to sell 50 tickets, so 50 should take the place of T. So 15 times 50 plus 6 times S, or 6S, needs to be 900. 15 times 50. Well, 15 times 50, we need to know what that is, and that looks like it's going to be 750. Plus 6S is equal to 900. Well, to solve for S, this is a two-step equation. We subtract 750 because we want to get X by itself. I do it to both sides. I get 6S is equal to 900 minus 750. That's 150. And then I just need to remove this 6. And this is 6 times S, so we divide by 6. And what this tells us is that 150 divided by 6, the number of snacks I need to sell is 25. So I, or this team, would need to sell 25 $6 snacks. Make sure you give it your best shot to answer these questions in this Edpuzzle, and enjoy the rest of your day.